Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Many of our friends requested for some most asked Spark interview question series. So today we will see one such question, which is like, what are the optimizations that you have used in your project? So while discussing about this, let's list out the main optimization techniques that we have to take care while writing the code. So first one is using the map partitions instead of map. So I have made a separate video with the detailed differences between map and the map partitions. So you can go through that. I'll give that link in the I button. But remember to tell this in the interview, okay? And next one is catching the RDD or data frame wherever is required. And once the catching, if you are doing through persist, you have to unpersist the data once the computation is completed. And when you are doing caching, that's fine. Spark will take care of uncaching that by default. And use maximum parallelism using the repartition and coalesce wherever is applicable. If you are dealing with a lot of data, use more repartitions by checking the memory available in your cluster. Also try to avoid shuffle operations, and in some cases we cannot avoid using the shuffle operations, right? In such case, see whichever is the optimized function, use that. For example, use reduce by key instead of group by key. So these by key operations also, I have given a very detailed video about the differences between reduce by key, group by key, sort by key, and etc. all the available keys. Okay, I will give that also in the I button. Just go through that. Okay, so this what is it? This video is mainly for the main points that we have to answer in the interview. And if you wanted to know the detailed information, you can please open the previous videos where I have given a very detailed information about the all these optimized functions. And next one is check the memory settings and provide the executors and the code details for while submitting the Spark job in the Spark submit command. So you can go through the Spark that memory management video, and based on that you can calculate based on your cluster, take your cluster memory, available memory, and you divide how much we have to provide for the executors and cores. This will also help in the parallelism and this will improve the Spark job performance. And some things to remember in the code is avoid using the collect. Also use the adequate serializers in the code. Spark uses, by default Spark uses Java serializer because it internally it uses JVM mechanism, right? So it uses the Java serializer, and it's actually pretty good. And it also supports some serializer called Cairo serializer. You have to set some setting like arg apache Spark serializer to Cairo serializer, and you can use it. It's 10 times faster than the Java serializer. But just see, okay, in which cases you have to use which serial based on your requirement, based on your data, and based on the computations that you are going. Based on that only, if you need the serialization to be have more in your code, if you have to do the serialization before even performing any computations, that time you decide on which serializer we have to use that in the code. And use appropriate APIs. For example, if you are doing some low level operations, then use the RDDs. If you are working on some data manipulations, column wise data you are dealing with, and if you have to perform some joins, then use the data frames. And based on the Spark versions, you can go for data sets as well. That's a highly type safe, and data frames and data sets, they provide very good garbage collection, inbuilt garbage collection, and they have this tungsten engine, and they have this catalyst optimizer benefits, right? So you can use them. So based on whatever the version, Spark version you are doing, what kind of data you are dealing with, and what kind of computations you are going to do on your code, based on that select the appropriate APIs. And use the advanced variables wherever is applicable. Advanced variable like broadcast or accumulator. If you have a very small table, then you broadcast it, and when you are doing join, right? So when you are joining a small table with big table, you use the broadcast, and you can perform the, you can broadcast a small table, okay, that will give very good performance. And similarly, if you have something, you have to send back something to the driver, then use accumulator, uh, hold it, and finally send it back to the driver. So you can use broadcast and accumulators wherever is applicable. And use the proper file formats. We have ORC, Parquet, Avro, text, CSV, TSV, everything we have, right? So see what kind of operations you have to perform on the data. Based on that, select the file format. Sometimes you might follow some row based operations. You wanted to do column based operations. So there are many other, in the previous videos I have given, I have taken each file format and made a video like how to read and write. And before even doing that, I have explained the advantages and disadvantages of all these file formats in the previous videos. So out of it, you can just take the advantages and disadvantages of using these file formats, and you can decide which is the best for performing the required computations. That is very, very important. And avoid creating the unused objects. Like you use, you create some object but actually you don't use it, then remove them. You just cleanse the code before testing. So what will happen is these unused objects, right, they will be collected by the garbage collector, and it will be a GC overhead for the job, for the cluster. So it's better to clear them off. So always remember to have this garbage collection memory is less than 10% of the heap memory, so that you will get a very good maximum benefit out of it. And let's say you have submitted the job, and you see that it is running slowly, then you, after the job completion, you open the DAG from the UI, Spark UI, and analyze it. Once you open the DAG, it will give you the stages in which it is taking time. So you analyze in which stage the job is having it's running slow. You take which query is used and try to optimize that particular query, so that we can we can get the very good performance after resolving or after optimizing that particular query or that particular stage. So DAG helps much when analyzing these performance related things or anything, okay, which stage is taking more time, and which what is it, executor also it will give. From UI we can get all these details and we can try to optimize. Okay, so these are the points, these are very good, very enough for answering in the interview, okay. And for the job also, when you are working on some Spark job, then these point, if you verify the points that are mentioned in this video, right, this itself will give you very good benefit for improving the performance of a Spark job. Hope this is useful to you, friends. Thank you for watching the video. And if you are looking for any Spark relay interview questions to be answered, please inbox me. We will discuss about all those Spark interview questions. Please subscribe to my channel for more interesting learnings. Thank you, friends.